Good day everyone. So today I'm going to share with you another discussion video, which is it will be all about the length of a curve. So how to get the length of the curve using your integral calculus. So let's try to define length of a curve. So this is another application involving the use of your definite integrals, which you need to solve for the length of the curve. So arc length would be the distance you are traversing through a path of a curve. So basically, this is the distance that you will take if you are traveling in a curved path. Suppose that you want to travel on this path here, which is y is equal to f of x, and you want to measure the length of the curve if you traveled from point 1 to point 2. Now, the thing here is you need to put a tangent line at a certain point so that you could solve for the length of the curve. So if I have my point P here, let's say this is point P, and I have my tangent line here, which let's represent as dl, or the change of length. So ideally, your change of length here should be very, 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 very small to get the approximation of the length of this curve. So by that, your dl, or the change of length, will travel or will start from point 1 to point P. Therefore, we could solve for the length of the curve. So if you will try to zoom it out, this is your DL, this is your curve, which is in length, and this one here, alright, is the dy. This is the change of y, and here is the change of x. So this is so familiar because this is a right triangle, and we could apply our Pythagorean equation here, or theorem, where to get the change of L, we could write an equation of dl, right, is equal to square root of dx squared plus dy squared. So if you want to get the length of the curve, you need to integrate both sides. So this one here, you get the integration, of the other side. So you will have L, which let's represent it as the arc length, which it is equal to the integration of square root of dx squared plus dy squared. If this L here will travel from your point P, or from your lower limit to the upper limit, you could get the total length of this curve. Since in this given curve that we have, we represented the curve as y is equal to f of x. So to get the length of the curve, we need to know our stripping, if it's in dx or dy. So again, for this example, we represent the curve as y is equal to f of x. So there will be a change in terms of x. So you need to multiply dx squared all over dx squared to dy squared. So you will have length, right? Or dl should be L. Small letter L, just write it here, L is equal to integration of dx squared plus dy squared. Then I need to multiply it by dx squared all over dx squared, right? Because, again, there will be a function of x here. So there is a change in terms of x. So we could factor out um, dx here or dx squared here. So you will have length is equal to the integration of square root of 1 right? Let's factor out dx squared plus dy squared all over dx squared, right? Quantity dx squared. And getting the square root of dx squared, this is equal to dx. So we need to get the square root of dx squared, which is, it is in dx. So I'll just erase this and I'll put dx outside the roots. So if your equation or your curve is in terms of f of x and it's changing, y is equal to f of x, it's changing in terms of x. So you make use of this equation, right? The length of the curve is equal to the integration of the square root of quantity 1 plus dy squared all over dx squared, or you just simply write it this way. Dy all over dx quantity squared, right? Dx from your lower limit a to upper limit b. Let's say a is your lower limit and b is your upper limit. So this is the formula. That's, I'll rewrite it again. So this is, okay. So this is the formula again. Length is equal to the integration of the square root of 1 plus quantity dy all over dx quantity squared dx from a to b. So this is how you solve for the length of the curve. This is one of the formula of getting the length of the curve. So if you have a function which is x is equal to f of y, this is the time that you will divide your dx squared by dy squared all over dy squared. Take note, because it's a function of y, there's a change of y. So our equation here should be in terms of dy. So our length of the curve is equal to the integration of the square root of dx squared times dy squared all over dy squared plus dy squared. So we need to factor out dy squared in our equation here. So we have the integration of the square root of dy. Okay, let's have dx first. Dx squared, right, all over dy squared plus 1 quantity dy squared. So get the square root of dy squared, you will get length is equal to the integration of the square root of dx all over dy quantity squared plus 1 get the square root of dy squared, that's dy. And if your length will move from your lower limit to the upper limit, you will get the length of the curve. So let's say our lower limit is a to the upper limit, which is b. So this is another formula to get the length of a certain curve. Now, let's try to find the length of the one branch of the curve ay squared is equal to x cubed from x equals to 0 to x equals to 5a. So the thing here, you are asked to find the length of only one branch of the curve. So the first thing that you need to do is to get the intersection points. So we are given with the parameters that we have x equals to 0 to x equals to 5a. So at x equals to 0, you have ay is equal to x cubed, ay is equal to 0, then y is equal to 0. Then at x equals to 5a, you have ay squared is equal to 5a quantity cubed. So you have y squared is equal to 125 a cubed all over a. So you have to get the square root of both sides. So you will have 125 square root of 125, then you have a. So let's try to simplify. This is y is equal to 5 square root of 5a. So these are our intersection points at 0, 0. Then you have 5a, 5 square root of 5a. Square root of 5, then a. So these are our intersection points. Now, we need to graph it. So, according to our problem statement, we just only need one branch. So, therefore, because we get the roots of this is positive, negative, positive, negative. So, we just need to have positive 5 square root of 5. So, now we could draw our curve to visualize it. Right, this is our x and y. Now, we have one parameter which is from 0, and then our second parameter which is x equals to 5a. So, we just only need one branch. So, kuha na to si first quadrant. So, we will have 0, 0 here. And then, let's say we have 5a, then 5 square root of 5a. So, this is 0, 0. It's around 11.2. So, let's say that this is 11 here, or yeah, that's 5 square root of 5, that's 11.2. So let's say it's here. So this is our curve. Imagine that it's a perfect curve. So let's label our curve, which is this is equal to ay squared is equal to x cubed. Now we are trying to ask for the length of the curve. So you need to draw your strip. But take note that your strip matters to the equation. So it's up to you if you will make use of the equation of length in terms of change of x, or it will be in terms of change of y. So therefore, our strip here, we just write or label it as the dl, or it means the change of length. But in your working equation, it's up to you if you will make use of the change of x or the change of y, or the dx or dy. So for this example, maybe I'll make use of the dx para dali lang. So you have L, or length of the curve, or arc length, is equal to the integration of the square root of, I'll just write immediately my work equation here. 1, it's 1 plus dy all over dx quantity squared dx from a to b. So this is now my working equation. Now this is the right time that I need to substitute the values. But I need to get the value in terms of dy over dx. So from my working equation, which is, or the curve, is equal to ay squared is equal to, sorry, x cubed. So I have ay squared is equal to x cubed. So I need to isolate dy over dx. So I need to do um, implicit differentiation. So this is now equal to 2ay dy is equal to 3x squared dx. So I need to isolate again dy all over dx. So I need to do cross multiplication. So this is dy all over dx is equal to 3x cubed all over 2a. Right? Which I still have values for y. So 2ay. Which I need to get the value of y. Again, we need to have in terms of change of x here. So you will have dy all over dx is equal to 3x cubed squared all over 2a, which the y value is from here. So I have y squared is equal to x cubed all over a. You get the roots of both sides. So I have y is equal to square root of x cubed all over a. So I have square root of x cubed all over a. So take note that this is dy all over dx quantity squared. So I could do square root the both sides. So you will have, I just write it here. So I will square the both sides. Dy all over dx is equal to 3x squared all over 2a, right? Times the square root of x cubed all over a. Square the both sides because from our equation, that's this quantity dy all over dx quantity squared. So we just simply substitute it later on. So square both sides. So we have dy all over dx quantity squared is equal to 9x to the fourth all over 4a squared times x cubed all over a. So we could cancel out a here, and this one becomes 1. And we could cancel out x cubed and x to the fourth. So this becomes 1 also. So you will have the value for dy all over dx quantity squared is equal to 9x all over 4a. So this is now the value that we need to substitute to the to our working equation, 9x all over 4a. So with that, now we could substitute the values that we have. So our arc length is equal to the integration of the square root of 1 plus our quantity dy all over dx quantity squared is equal to 9x all over 4a times dx from our lower limit 0 to the upper limit 5a, which your parameters should be in terms of x because we are doing change of x here. So now we will have to evaluate this. So this is equal now to the integration of the square root of, maybe let's get the LCD, which is 4a. This is equal to 4a plus 9x dx from 0 to 5a. So we will have to factor out square root of square root of 4a in our integral element. So we will have 1 all over 2 square root of a, right? Take note that this one is still part of the radicand, yung 4a. So we have 1 all over 2 square root of a, integration from 0 to 5a of square root of 4a plus 9x dx. So now maybe we could apply basic rule of integration, right? Or we could do substitution, u sub. So u substitution, so maybe we will let u is equal to 4a plus 9x, and our du is equal to 9 dx, and our dx is just equal to du all over 9. Now, we could substitute the values that we have from our working equation here. So we have 1 all over 2 square root of a integration of 4a plus 9x, that's our u. So you have square root of u times our dx is just equal to du all over 9. Now, because we are now in terms of u, maybe we could also change our parameters. So instead of x, maybe we will have it in terms of u. So at x upper, which is equal to 5a, you have u upper is equal to 4a plus 9 times 5a. This is equal to 4a plus 45a, which this is now equal to 49a. So u lower at x is 0, which is x lower is 0. U lower is equal to 4a plus 9 times 0, and this is now equal to 4a. So our new limits now is from 4a to 49a, because we changed the parameters that you have. Now we will have in terms of u. So now our new working equation is equal to 1 all over 2 square root of a integration from 4a to 49a of square root of u times du all over 9. Now from there, I'll just write it here. We have 1 all over 2 square root of a integration of, maybe we will integrate it using our power rule. So this is equal to u all over 3 halves raised to 3 halves, u raised to 3 halves all over 3 halves from 0, 14, 4a, from 4a to 49a. Okay. My a and 9 is similar, so I just rewrite it. It's 4a to 49a. So we could cancel out 2. Then we still have 9 pa pala, so we still have 9 here. So this is equal to 1 all over 27 square root of a. Alright, 1 over 27 square root of a, u raised to 3 halves from 4a to 49a. Now we will have 1 all over 27 square root of a. Then we have 49a raised to 3 halves minus 4a raised to 3 halves. So this is equal to 1 all over 27 square root of a. Then this is 343a raised to 3 halves minus 8a raised to 3 halves. So we will have 1 all over 27 square root of a times a quantity of 33335a raised to 3 halves. Alright. Then we could cancel out this one. So 3 halves all over 1 half, that's 1. So we have now our final answer as 335A all over 27 unit. So this is now our final answer. This is the length of this curve here. By the given equation that we have, or the given parameters that we have.